because now we're going to write equations of polynomials that have imaginary roots to them, which is going to change up, a little bit about what we do. Let me ask you this, first at the top. If you have a root at 5, what's the factor? X minus 5. We're all pretty good with that, okay? What's going to get trickier is that, let me think about this. What if you have a root at 1/2? What's the factor? Right, you're all going to want to write x minus 1/2. Unfortunately, you're not allowed to have a fraction in there, okay? So it's easy when it's a whole number, because if this is truly what you're doing, whether you realize it or not, if the root equals x, you're essentially getting this equal to 0. You're kind of reversing the teeing it up concept. So you're subtracting 5 from both sides, so this says x minus 5 equals 0, right? What do you think it is? Very good. So Maggie's obviously pretty good at thinking that through in her head, but that's tough to do for most people, okay? So the reason I'm showing you this reverse teeing it up process is because think about if we wanted to get this equal to 0, multiply by 2 on both sides first, which would leave you with 1 equals 2x, and then subtract the 1 over, so you'd have 0 equals 2x minus 1. That's your factor. Does that make sense? Okay, when it's a whole number, so much easier. You're like, oh, just flip the sign. If it's a fraction, you've got to think through that process and actually get it equal to 0 without having fractions involved. Okay, let me try another one. Try this one on your own. If the root is 3/4, take a minute to come up with the factor. What do you think? Very good. Multiply by 4 on both sides. You get 4x equals 3. Subtract your 3 over. You get 4x minus 3 equals 0. 4x minus 3 is your factor. Okay? So, did anything like that come up on last night's homework? No. Okay, so now, I wish I actually should have talked about that yesterday. Now it does. Yeah, Nathan? It will, but I would prefer that you adopt this rule of just like get it equal to 0, only because it's going to be the same rule for imaginaries. Right, it's a shorthand rule for just working with fractional roots, but that same shorthand rule is not going to work for imaginaries, whereas this concept of getting it equal to 0 will. Does that make sense? Okay, so when we're dealing with imaginary roots, there's 2 key things you have to know today. The first one you sort of have already known. Imaginary roots come in pairs of conjugates. So if a plus bi is a root, then so is a minus bi. So most often they're going to give you one imaginary root. You're going to have to know the other one on your own based on this conjugate idea. Is that understood? They're probably only going to give you one of the 2. You have to come up with your other one based on the conjugate. That's issue number 1. The second key is going to be coming up with the factors based on this idea. Based on if they tell you the imaginary root, coming up with the factor is going to follow this concept. So let's just jump right into exercise 3. Write the equation of a cubic function in standard form that passes through the point 2, 4 and has roots of 5 and 2 plus I. So first of all, Here are your roots, 5 and 2 plus I, and as I promised, you have to come up with your second conjugate imaginary root, which is what, Cameron? Okay, so what's the imaginary roots come in pairs of conjugates, so what's the conjugate of the 2 plus I that they gave you? There you go. So now we have our 3 roots. So that was the first key concept, knowing about that second imaginary root. Now, changing these roots into factors. Okay? The 5 is easy. The factor is x minus 5. The other 2 are going to be a little bit more difficult, right? Because if your root equals x, and you're trying to get this thing equal to 0 to come up with the factor, I have to subtract the 2 over and subtract the I over. Do you follow? So subtracting 2 and subtracting I, subtracting 2 and subtracting I, the factor is x minus 2 minus I. Do we follow? Nathan, you see what I'm saying now about that 0 idea? I prefer, if I'm going to, you can always make more rules, but then you've got a rule for each and every little thing. So if I can come up with one rule that encompasses and can be followed for everything, I'm going to do that. I'm going to keep less rules, because then there's a better chance you're actually going to remember one rule versus 3 little itty-bitty ones. Okay, and what's this next factor going to be? Try to come up with the next factor based on that same concept. Ooh, 2 people have already got it. Take a minute, everybody. Try to figure it out. Isaiah, is that a hint? Good. What is it? X minus 2 plus I. So if this were to equal x, I got to get it equal to 0. Add I over, subtract your 2 over, so x minus 2 plus I. Okay? Nathan? Yep, you could, if you want to do that. I just tend to keep my x positive right from the get-go, so yeah, that's fine. All right, so now going back to your general format. The one that we used yesterday is still going to be the same thing. Y equals A times, and then go and plug in all of your factors. We already came up with them, so x minus 5, x minus 2 minus I, and x minus 2 plus I. Now, when imaginaries are involved, before plugging in your point, because we obviously have a point xy that we're still going to plug in, no polynomial equation is ever going to have I in it. No function has I in it when it's finally written. Obviously, in the intermediate moment, there's I's in there. The first thing I always want you to do before plugging in your point, just because it's going to make your life easier in the long run, is multiply out the imaginary conjugates. Okay? Now, there's 2 different ways you can look at this. You can look at it as a trinomial times a trinomial. You can distribute your x through all 3, distribute your negative 2 through all 3, and distribute your negative I through all 3. That's probably a little more straightforward, and maybe I'll say better. The other way of looking at this, which is how we've kind of looked at conjugates in the past, is that these trinomials are in fact conjugates. X minus 2 minus I, x minus 2 plus I. But you have to look at the x minus 2 sort of as a package deal, right? So if we kind of foiled this, we would do x minus 2 times x minus 2, which would be x minus 2 in parentheses squared. I was sort of debating doing that out on my own. But anyway, yes, x minus 2 squared. Your outer x minus 2 times positive I and your inner x minus 2 times negative I are going to completely cancel, which is nice, right? You have x minus 2 plus I, or the x minus 2 times the positive I, and the x minus 2 times the negative I, which are going to cancel. And so then your only other term is your last times your last in foiling. Negative I times positive I is negative I squared. I'll put that in brackets. Your x minus 5 is still there. Your a is still there. And what happens to this? What's negative I squared the same as? Minus negative 1. Right, minus negative 1 is going to be plus 1. So y equals a times x minus 5 times x minus 2 squared plus 1. Are you with me? Now that those i's are gone, I can choose to plug in my point and find a. Okay? But actually, even before that, this needs to be cleaned up. Right? I should actually square this out, which again, this is kind of the squaring of a binomial that I want you to be able to do in your head. That's x squared minus 4x plus 4 plus 1. So this whole next factor is really going to turn into a trinomial. X squared minus 4x plus 5. Now I'm going to plug in my point. Okay? So now that my imaginaries are all gone, and by the way, anytime you have two imaginary roots, they're going to make a quadratic. When you multiply them all out, they're going to make a quadratic factor, because that quadratic factor has imaginary answers. Okay? There's no way to really write a linear factor without an I. It's going to have an imaginary root. So from here, let's plug in 2, 4. So 4 will equal a times negative 3. What's my quadratic going to boil down to? One. 2 squared is 4. Minus 4 times 2 is minus 8, so 4 minus 8 is negative 4, plus a 5 is 1. And negative 3 times 1 is just negative 3a. And we divide both sides by negative 3. Now, I don't know how much this happened on your homework last night, but I think it did happen once. A does not have to be a whole number. A can absolutely be a fraction. And when you divide both sides by negative 3 here, a is going to equal negative 4/3. And so I am definitely not going to go back to the original and plug in negative 4/3. I don't want to deal with these imaginary roots again. Part of the reason I wanted you to get rid of them right away is so, could you imagine plugging 2, 4 into that and figuring out what to do with all those i's? So getting rid of it right away really brings you to here. And then you can treat the problem normally. Kind of working out that imaginary nonsense, getting rid of it all, and then working from here. So now that is where I'm going to plug in my negative 4/3. And hopefully, in most cases, be done. What I think I've noticed on the regents is that that's enough, okay? Usually on that, they're not going to ask you to put it in standard form, although annoyingly enough, this particular one did. If they tell you to put it in standard form versus factored form, what do you have to do here? Distribute, exactly. And I am definitely not going to distribute that negative 4/3 until the very end, right? Because I don't want to work with fractions any longer than I have to. I'm going to do this first. X cubed minus 4x squared plus 5x minus 5x squared. I'm just going to line that up under the other x squared term, plus 20x minus 25. So that would all be x cubed minus 9x squared plus 25x minus 25. with the negative 4/3 out in front. And then now distributing the negative 4/3 is not terrible, okay? I'm going to, I'll go up here because it's the only place I have room. I'm just about done. If I distribute my negative 4/3, negative 4/3 times x cubed is just what I said, negative 4/3 x cubed. What's negative 4/3 times negative 9? How many thirds? Negative 4/3 times negative 9 is how many thirds? 36, right? Negative 4/3 times negative 9 is 36 thirds. What is 36 thirds as a whole number? 12. So that's plus 12 x squared. Negative 4/3 times 25. What's negative 4/3 times 25? How many thirds? Negative 100 thirds. Leave it that way. We are definitely not going to turn that into a decimal. If it's a gross fraction that doesn't simplify, just leave it. And then negative 4/3 times negative 25 is a positive 100 thirds. So that's pretty ugly in standard form. I'd be shocked if they had us do that. But do you see now why I'm telling you that your Algebra 1 skills of distributing have to be on point for today's stuff? The conceptual stuff isn't so much of a reach from where we were yesterday. It's just a lot more algebra going on, so it's a lot more intensive that way. Okay? Any questions on that? Okay. This one's not going to be so bad because it's not imaginary roots that we're focusing on here. It's just, if you notice yesterday on your homework and in your notes, they always told you what the roots are, like verbatim. You have a root at 5. You have a root at 7. They're not telling you that today. They're showing you a picture so that you can extract that information on your own. So Connor, tell me where our roots are. Negative 3, 2, and 5. Anything of note about any of those roots? Wink, wink. Mason? Yeah, it's a double at 2, so right maybe double next to that. So now when we come up with our factors, and you know, these aren't too difficult, so I'm just going to go right ahead to my format. What is the rest of this format going to look like, Aiden? Get us started. Perfect. Awesome. That makes sense to everybody? So we pick up on the double root due to that bounce, which affects our equation. We have to, what would normally come next? Because you always have to find A, so what would come next? What would we do? Plug in a point. Did they give you a point? Not on a silver platter, but they've definitely given you enough, right? What point would you want to use, Kaylee? Negative 2, negative 4. I don't know if that, yeah, you know what? I think that is probably exact. Any other ideas? Nate? The y-intercept is a great option, although is that happening exactly at negative 2? I think so. Let's assume it is. Anything else? To be truthful, I think that they'd be a little bit more clear about it. I think they would kind of put a coordinate pair next to this and would give you that because this scale isn't perfect. But you would have to grab a perfect point. No other ideas? Nathan? So that's what I was hoping someone would say, just so we could talk about why you can't do that. So if you picked a 0, unfortunately, like if I picked negative 3, 0, and I plugged in negative 3 and 0, it's going to make it's going to be 0 equals 0, right? So it's not going to give you anything to find A. So you have to pick a non-root point to put in. Is that clear? Okay. So let's just do 0, -2. If you want, Kaylee, I'd love if you did -2, -4 on your own and see if we get the same answer. So, what did I say, 0, -2? What happens to 0 minus 2 when I square it? 4, good. A, 3 times 4 times -5 is -60, yes? 12, okay, so -60A. So what is A in simplest form? 1 over 30, good. Kaylee Smith, did you happen to get the same thing? Oh, okay. And you honestly may not, because -2, -4 might not be the exact point, but I think it is. Sure, it'll be close to 1/30th if it's not exactly 1/30th. But again, they'll give you an exact point. It will be clear. So pick a perfect point that the graph goes through. It's not something that you're estimating, and it will give you the right A value. So all we have to do is go back and plug that in up here. So honestly, you could go back and just erase your A and plug in 1/30th and circle that as your final answer, because this one does say write the equation in factored form, thank goodness, because I don't want to multiply all that out. Okay? Did you get 1/30th?
No, I got 128.
So it's really close. So that's because one of our points isn't perfect, but we will avoid that on homeworks and tests. Okay, on the last one, write an nth degree polynomial satisfying the conditions below. So this is exactly phrased the way some of yours will be on the homework. N equals 4. So it's a 4th degree polynomial, so how many roots should we have? 4. So y equals A. They're telling us we have a root of 2 with multiplicity of 2. So what's that going to look like? X minus 2 squared. Very good. And they're telling us we have a root at 3i. So what's that factor going to look like? X minus 3i. Right? The factor will be x. That's a nicer imaginary root because it's not a binomial, right? The binomial made it a little bit uglier. But if your root is 3i, then your factor will just be x minus 3i. So there's 2 roots, the same one twice. There's your 3rd root. How come they haven't told us the 4th root? Conjugate. So if 3i is a root, then so is negative 3i, which means what will the factor be going along with that? X plus 3i. And of course here they're giving us the point, 0.36. So we would plug in 0 as our x and 36 for our y. Ooh, or would we? I don't want you to plug in the point right away, right? I told you that because when I plug it in with imaginaries, that's going to get crazy. Can we FOIL this out first? FOIL the imaginaries out first before plugging the point? And these are conjugates, so it's x squared. Your outer plus 3ix and your inner negative 3ix are going to cancel, and I'm going to get minus 9i squared, which is going to turn into what? X squared plus 9. Very good. X minus 2 squared, A equals y. And from here, I would plug in the point 0.36 to find A, which we're not going to do, just because I want to jump to the back. Any questions on that? Okay, so that point forward should be pretty clear, I hope. Again, I can't stress it enough. Don't plug in your point until you've worked out the imaginaries. Get the imaginaries gone, then plug in. It's going to make your life less confusing. This is more of the same, so I'm not going to do that one. This is more of the same, so I'm not going to do that one. Notice on this one, though, again, we haven't talked about it since the beginning of class today, there is a root at 1/3. Okay, maybe we just practice this one more time quickly. Here's our roots that they're giving us. So what's the factor that goes along with x, a root at -4? X plus 4. What's the factor that goes along with 1/3? So this might take some side work. If x equals 1/3, can you visualize what that factor is going to be? 3x minus 1, because we have to multiply by 3 on both sides, and then subtract the 1 over. Very good. 2 plus 3i. So if x has a root at 2 plus 3i, when you subtract things over, what's that going to be? X minus 2, x minus 3i. And then the other root is going to have to be the conjugate of that, 2 minus 3i. So when you subtract things over, what's going to happen there? Perfect. Now, do you remember I said before on the front side, and I'll put the a out in front equals y, I said that you can see this as conjugates, or you can multiply through 1 by 1 by 1 by 1 by 1. Does that make sense? Just watch. I'm going to fly through this. I don't want you to copy it down. Just watch how the 1 by 1 process would work. X squared minus 2x plus 3ix. Move to the -2. Minus 2x more. I'm going to line it up under here. Plus 4 minus 6i. Move on to the -3i. Negative 3ix. I'm going to line it up under here. Negative 3i times -2 is plus 6i. I'm going to line it up under there. And negative 3i times positive 3i is negative 9i squared. So do you see how plus 3ix minus 3x will cancel? Negative 6i plus 6i will cancel. And this is going to turn into a what? Plus 9. So it's going to be x squared minus 4x plus 4 plus 9 is going to be plus 13. And there's that trinomial we talked about. And so once we've worked out those imaginaries, this is when I would now plug in the point 1/100. Are we good with that? Okay? When you see graphs like this on your homework, this is going to be like the graph I showed you on the front side. The window is at the bottom. So look up at the board here. The fact that this says -6, 6, 1 is saying that the x-axis is going from -6 to 6, counting by ones. The y-axis is going from -40 to 40, counting by tens. So that would be -40, -30, -20, -10, 0, 10, 20, 30, 40. Do you follow what that means at the bottom? That's giving you the scale of the graph that you're looking at so that you can pick a point. Okay? Like this y-intercept, for example, is 10, 20, 30. So I would say use the point 0, 30 once we get there. Okay? And on the very last two, solving. Okay? These are not going to be factorable. So if they're not factorable by hand, how can we solve them? Plug it in. So I will just plug in the function. Why is my calculator not clearing all this nonsense? Okay. 6x to the third minus 11x squared plus 6x minus 1. And it already equals 0. If it hadn't, we would make it equal 0. And then look at your graph. I did a -10 to 10 window. Is that a good window? Okay, it's positive odd, so it starts low, ends high. I might want to focus, just kind of narrow my X window in and just focus in on there a little bit. and even narrowing my y. What if I go from negative 5 to 5 and negative 5 to 5? See how it bounced a little bit there? I want to zoom in further on because I'm looking for the 0. So zoom in, and I can go right into here where I'm curious about, and I have 3 roots. Do you see them? Second, you don't know that until you zoom in, but trace for that 0, trace for that 0, and trace for that 0. If you weren't zoomed in enough, you might think it was a double root, right? It's actually 2 different roots. You can see it barely coming above the x-axis. Okay. Your homework tonight's going to look a little bit funny because it's not from the same resource that it normally is, but the answers are still written there. You only have